All right, now we're going to have a lot of fun with this code because I had tremendous amount of fun restoring images. So let's take a look. I will start off with cloning the GFPGAN and enter the GFPGAN folder. And then the percentage CD content, it sets up the environment for using GFPGAN. And then we will remove with this code any existing GFPGAN directories, and this will clone it from the repository of GitHub like we were referring to before. We will change directory to the newly cloned GFPGAN directory shown here. And then like we had spoke about, we'll set up the environment, we'll download and pip install the libraries that we don't have yet installed, and specifically you have to reinstall them every single time on Google Lab or Google Colab. And then once we have all set up the environment, then we'll download the pre-trained model here. And then we will import our libraries, read the image path shown here with the color of PGR to RGP because we're using CV2. Here's a list of paths that we have in the folders for the cropped faces, and our system will now read them and then show the images. And you can see those images here. I actually had different images up, but I didn't see really good quality of those images, so I readjusted it and used these images instead. And you can see they're not that great of a quality. Now we're gonna do, we're gonna have to go ahead and modify specific lines in our code because we were getting errors. So this will be the function to be able to modify the code for that. And these are the three scripts that we have to modify where we were getting errors, and we're actually gonna it would have to do with the transform function tensor so we had to delete that unfortunately and just put just the functional aspect. I don't know if you can see the difference, so we transformed the two, and then we wanted to verify that these modifications had happened, and then we're going to run the GFPGAN inference script so we can visualize these images. Now, to be able to visualize the images, we're going to have to define the function to read the images using CV2 and the pathway. And then here's where the results of the function of the images are. And then we're going to have to read the images in that image list and then show the images with plot show. And now you can see the difference of them. A little bit clearer. It seems surreal to me a little bit, but as we go down, it doesn't seem like this guy changed very much. I have another image where he does change quite a bit. And then Marilyn Monroe definitely has better sharpness and quality of the image to her facial features. And then this serviceman as well, just like Marilyn, has less noise and better sharpness and facial features as well. Definitely clear and real, like lifelike. This woman, she had lines before on her face and they seem to be not very noticeable except for the one here, and they gave her some color enhancement to her face. I can see a little bit more color in her eyes and her lips. And now we're gonna try and do inferences for whole images, and that I'm gonna skip some of this because it's very similar to what we did before, but you can see the before and after of these photos and how just the enhancement of the facial image. Now we're going to do the Jim Henson from the Muppet Babies, if you remember that show. We're going to do a whole restoration from the real GAN, where we enhance the background as well as the facial feature. And it's very similar to what we did before with the coding. Similar here as well, we had to modify the different Python libraries. And then we had to move the image using the importation of Shidle. And this is where we move the image from this directory to this directory. And then we're going to have to use both the inference for GFP-GAN as well, and then also the same for real ESR-GAN. And then this is going to be where the image is stored to verify the output. And there is where this is the code where we get to visualize the results. And now you can see the difference in the facial feature. He looks a whole lot younger here by far. The color, the brightness, the hair, the beard, definitely shinier hair. It even seems fuller. The beard seems fuller here. The sharpness and clarity is enhanced. The noise has been reduced significantly. A way more polished look. And then we want to see the whole image again of the Jim Henson, like it was when we first put it in the input folder. And this is how we would code for that. And this is the differences. And you can see how better this image is than this image is. And a little description about it, how we restored it. And now I wanted to really do some masking of images that have scratches on it and try to figure it out. And then we had to use this model here from the GitHub library, as we talked about. And then we used create a directory for the weights here. Use this function here. Then this will loop through the dictionary of model URLs, checking to see if the file already exists. And if so, we're going to have this print statement here. And this print statement here is used to verify that the required model weights have been downloaded successfully, which they have. And then we're wanting to enhance the real ESR-GAN with this special code here, and then the GFP-GAN with this code here, since we're doing both for the whole image. And then we need to enhance and display images side by side with GFP-GAN. And it will display the initial and the enhanced photo side by side, and it defines a function to read and enhance and save the image and handles exceptions if the enhancement process fails. The images are then loaded and displayed using Matplotlib and the Pillow library. Oops. And you can see the before and the after, and how there's more color here. You don't even notice the scratches as much. You know, some of the scratches have been removed in the facial area. And you can tell that, you know, she actually looks younger, even though she's just a child. And then we did the same for this woman, same way. This as well, more color in the face, more sharpness as well. And we wanted to now use masking with that little girl to remove those lines in her face and see if we can restore it then using this code. And this is the masking technique with that code that I just showed you. And this is the output. So like we got that mask done, we got the lines out, but then when we wanted to apply the GFP-GAN technique application, this is how her face turned out, which really doesn't look like the other photo that we just saw. But in all, my whole heart was to use artifacts to restore. So I asked, just like our project asks of us, to put into a generative model like ChatGPT to give us some code as a sample. I just did that because we were told in this final project to do so. So this is, what it gave me: the loading the images, the pre-processing of the images, and definition for each of the functions that's happening in the code, along with the restoring and post-process of the image and how it needs to, restore the image pixel values by 255 to scale them back to the range of 0 to 255. That's what it's doing here in the function. And then it's going to display the before and after photos of the artifacts that I want it to restore in the sample code. And this is the overall process of what it takes to be able to try to restore an artifact in real life. And this is the before and this is the after. This is the before and this is the after. And you can see how we were hoping that it can actually restore that image and then give this image a little bit of color. And that is the end. Thank you very much.